In this video, we're going to pick up from where we left off in terms of calculating the skewness and kurtosis of a sample of data. And in the previous video, we ended up by calculating the z-values for each of the corresponding raw scores. The next step is to take each z-value and raise it to the power of 3 for each of them, and I'm going to put that in this cell in column E. So I'm just going to hit the equal sign. I'm going to click the cell that has the value that I want to raise to the power of 3. And I'm going to shift 6, which is going to raise the next number as the exponent to the base of the number located in cell D2. And I hit enter and I get the value 16.86. Now I'm just going to do the same thing. I'm going to use the click and drag option here to perform the rest of the calculations. So I hover my cursor over the bottom right hand corner, I click the left mouse button, and I click and drag, and I have the cubed z-values all the way at the bottom, all the way down to the last data point. And the next step is to sum all of these values together, because we'll need that to calculate gamma 1, which is the classic equation for skewness. So once again, I'm just going to use the Excel function sum, shift 9, and I'm just going to add up all of these numbers. I shift 0, and now I have the sum value that of the cubed z-scores. Now I need to do the same thing for the next column. I need to take each z-value and raise it to the power of 4, and we'll need that for the kurtosis calculation. So I'm just going to hit the equal sign, and I want this value right here, and I'm going to raise that, shift 6, to the power of 4, and I hit enter. And once again, I'm going to use the click and drag option to calculate the rest of those values. Now I also need to calculate the sum of these values, so I'm just going to make this convenient. I'm going to click the sum function in this cell. I'm going to grab the bottom right hand corner and I'm just going to move it over. Now if I click on this cell and I go up to the formula bar, I see that I've calculated the sum of F2 through F15. So that makes it a little bit more convenient. The next step is I'm going to calculate the skewness using the classic equation here, and in this equation the summed value of the cubed z-scores, which is the numerator, is just simply going to be divided by the sample size, and the sample size here is 14. So I'm just going to hit the equal sign. I'm going to find that summed value, which I have right here, and I'm just going to type in the number 14 because I know that's my sample size, and I hit enter. And I have a skewness value of 1.27, indicating that the data are distributed in a positively skewed manner, which means that the long tail is pointing and heading in the positive direction. The next step here is I'm going to calculate the kurtosis value using this classic equation, and the first step is to calculate the the fraction of the summed z-values raised to the power of 4 divided by the sample size, and then that quantity I'll then subtract 3. So I'll hit the equal sign, and I'm going to shift 9 because I want to keep the fraction. I want to perform that operation first. So I'll find the sum value. I'll divide that by 14. I'll shift 0. Now I can subtract 3 from this quotient, so I just hit the dash for the subtraction, hit the number 3, and I hit enter. Now I see I have a kurtosis value. It's not quite 0, but that's a little bit more than 0. 0, of course, meaning that it would be a mesokurtic type of distribution, which is very close to the normal distribution, but it's slightly positive here, indicating that it's more leptokurtic than mesokurtic. One more step here is I'm going to calculate the standard error of the skewness and the standard error of the kurtosis value, and you'll see that these values are solely dependent
on sample size and not the actual skewness or kurtosis values. So I'm going to start with the skewness standard error. I'm going to hit the equal sign, and I'm just going to type in the Excel function SQRT for the square root. I shift 9, and I'm just going to type in the fraction of 6 divided by the sample size, which is 14. I hit shift 0, and I have the standard error of our skewness value. And for kurtosis, the equation takes a very similar form, except that we, instead of using a 6, we use a 24. So once again, I hit the equal sign, SQRT for the square root, shift 9, and I type in 24 divided by the sample size of 14, shift 0, and I have the standard error of the kurtosis value of 1.31. So this ends this part of how to use Microsoft Excel to calculate skewness and kurtosis.